Hello everyone again. Uh, Today we'll be learning about networking. So I found a video here in YouTube and it is it's good. It's explaining you very well about the networking. So you can come here and search networking in 30 minutes. Yeah, the first video is a very good video. I really recommend it. I've already seen it, so we will watch it together.
In this video, I'm going to show you the essential networking concepts that every software engineer needs to understand. We will follow a simple approach, basically watch how one application grows from a single server to a complex cloud system, and learn each networking concept exactly when it becomes necessary. So meet Travel Buddy. This is going to be our imaginary travel booking website, and we will see how its networking.
Алло,
Алло,
слушай, брат.
кто-то хотел позвонил еще?
Нет, я не позвонил тебе.
Да, наверное, там не в сети был, я внутри зала, поэтому ладно.
Ну, ты сказал, что ты не успеваешь, все.
Ну да.
Вот, если не
Давай, ладно.
успеваешь, ничего не нужно, спасибо. Давай. Okay, sorry guys.
Needs evolved over time, and you'll understand why each networking piece exists and how it solves real problems. We also created a detailed handout that breaks down everything that I'm going to cover today, so make sure to grab it from the link below. It's completely free.
So yeah, here we have our, sorry, this phone is just killing me. I just don't want to use it. So here we have our networking and in 20 minutes, and I want to grab my, yeah, maybe we can use this thing. Wait a sec. We have this one. Google. Google Note. Google Note. Google Keep. So here you can keep your notes. It's online. You can just find it anywhere you want. So yeah, you come here. You just add the title, and that's it. Like net working in 20 minutes. So yeah, then you start taking notes. You can send screenshots, anything you want. Like you can, yeah. So I'm gonna take this and, oh, sorry. Wait a sec. I'm gonna put it here so I can take notes. And we can bring this thing here. And
So let's start at the beginning. When we first launched Travel Buddy, we had one server running our entire application. Simple, right? But immediately we faced our first networking question. How do customers actually find our server on the internet? Every device connected to a network needs an identifier so that other devices can send data to it. And this identifier is called an IP address. Think of it like a house address for mail delivery. Without it, no one knows where to send anything. So
I don't know, dear, I'm having some problem. Like when I'm listening to this video, and I have problem with this thing. I don't know why this thing is doing like that. So it's like, I don't know. He's explaining like robot, so the sound looks like robot. So yeah.
our Travel Buddy server got a public IP address, which looks like this. This means any device on the internet can send a request to this specific number and reach our server. Now, you may be thinking, Do I need to remember numbers like 203, 0, 113?
First of all, he's explaining one of the main thing in networking is IP address, like IP addresses, which is like Internet Protocol. The meaning is, I don't know why it's showing me this protocol. So yeah, Internet Protocol. So think it is like a home address. Like every home has its own address, and in internet we also just doing the same thing. Like each site has its own address, which is not like this street, like you need to come to this street, this the name of the street now, but they're just dealing with IP addresses, bunch of binary codes, binary numbers, I mean, yeah, numbers. So basically we have 203.113.10. And they are the IP addresses. And so yeah, each computer has an IP addresses. Without IP addresses, there's nothing impossible. We cannot send packets to anyone. I mean, yeah, without IP addresses, you cannot uh you cannot use internet. That's it.
And 10 to reach a website? No, just like you don't memorize phone numbers anymore, we don't memorize IP addresses either. And this is where DNS comes in. DNS translates easy to remember names into IP addresses. So when someone types travelbuddy.com into their browser, DNS automatically looks up the IP address that will look like this and connects them to our server. DNS works like contacts in your phone. Usually not type in the phone number, the actual phone number, you just tap on the name, like mom, and your phone finds the actual phone number in the background. Just like you type google.com and DNS finds the actual IP address behind that name. So now customers can find our server. Good. But here is the next problem.
Hmm. So then after IP addresses, here it comes the DNS. DNS. We have domain name server. And why we need this? Yeah, because nobody types the IP addresses there like 127.0.1.1. No one is gonna type it, or no one is gonna remember like the what do you say? The Google's IP address for reaching to the Google. So yeah, that's why we have DNS. So DNS, we have a separate server where everyone is gonna store their own names, I mean domains, and after that, so when we want to reach to google.com. So first of all, our request goes to the DNS server. From there, so google.com is going to be translated to the IP addresses, the numbers, and then it's gonna send to the real server I mean to the Google server. And so here it says like basically we have our what we have our phone and we have the numbers there, right? I mean our dad. So they have the number, but we saved it as dad. So we just go and search dad and we call him. So it's like say like an example how the DNS works. So it's like making the life easy. I mean, people cannot remember the numbers, and that's why they're just making the uh, life easy for people. So yeah, multiple
Our single
applications.
server is now running three different things: the website that customers see, a database storing all the booking information, and a payment processing service. All
Okay.
three share the same IP address. So when the request arrives at our server, how will the server know which application should receive it? This is where
Mm-hmm.
ports solve our problem. Ports are
Ports. Okay.
numbered channels on a server, ranging from
So yeah, we have when we want to reach to a server or a site. So they have basically three things. One, we have web app, so like a web application or just web, web address. I mean, this is a web. So this is a web right now I'm using. This is the web one, the web MySQL. I mean, it's the place where we store the datas, like all the datas about like me, the whole thing, like my name, my number, my stuff. It's like a storage. And we have payment service. Yeah, not server service. And payment service. So where's like we have the information about the payment services. And so yeah, when we give a request, so when I send a request to a server, we need, I mean, server need to decide where am I sending my traffic? Where do I want? Do I want to go to the web? Do I want to access my data? Or do I want to pay something? Pay for a service. And so yeah, here the ports come in. So ports is like the, how should I explain you? The sockets, like uh so yeah, I don't know, like I cannot explain it. Supports when the ports are coming. So when the ports come in. So we have different ports for I mean for all of them. So nice. I think they're gonna explain it. So let me just have the note here. So then we have ports. So a server, a server has has three three um I don't know, three main thing to reach. No. We cannot do that. So we need to server name, server. We have web app. We have web app. My SQL. We have payment service. Yeah. I'm just taking a note just like that. I mean, everyone's note taking is different. And guys, sometimes I make mistakes in English, and I'm so sorry for that because my English is not my first language. The English is not my first language. So yeah. Okay, we have the server here, and a guy wants to reach to these three things in a server. I don't know what we call it. So web app, MySQL, and payment service. And what is he gonna do? We don't understand right now. So let's learn it.
1 all the way to 65,535, and each application listens on a different port number. So let's say this is how we set up our application. The website listening on port 80, which is standard for web applications, or for a secure connection, there is a standard port for secure web application connections on port 443. Then we have a MySQL database listening on port 3306. That's a standard MySQL port. And then we have some custom payment service that we decided to run on port 9090. Now, when a customer visits travelbuddy.com, their browser automatically connects to port 80 or 443, and the server knows to send the traffic to the web application and not to some other program on the server. So think of it like apartment building. The building has one street address, that's the IP address, but inside the building there are different apartment numbers, like the ports. Great, so that's taken care of. But now we're growing and a new problem appears.
Mhm. Okay. So yeah, they explain about the ports. Like, I hope you guys learned it. So
appears.
basically, we have so in web apps we have 80 and 443. So 80 is HTTP and 443 is HTTPS, more secured version of web app. And for MySQL 3306 and for payment service 9090. So when we want to reach to a server, so our request, so we're requesting a web app, then our request comes to the server here, and server checks, okay, where we want to go. Then it like it checks that, okay, we're going to the web app, so then they're gonna send us to the port 443 or port 80. So that's like how he decides, how the server decides which port they're gonna send. So guess like a here also they told us like it's like a room. I mean it's like an apartment where it's like ports, it's like the room number. So 301, 302, 302. And we want to send a mailbox. I mean, we want to send a packet there. So we need to know the port there. So I want to send a packet to this apartment and I want to know, I know the room number. So it's like 302. I'm going to send it here. So yeah, it's like how the ports work. I don't know how, I hope you guys get it. So we have port 443, port 80 for web app, and we have 3306 for SQL, MySQL, and 9090. It's like for payment servers, I think it's different. So every company they will have their own ports. So yeah. So 9090 is for payment server service. What? How I take notes, I don't know. The girls take notes, like red, the red pen, blue pen, and some other pink pens. But guys, we just take notes randomly. The main thing is to remember to remember it.
Think there are different apartment numbers, like the ports. Great, so that's taken care of. But now we're growing and a new problem appears. Travel Buddy
Okay.
is now handling appears.
Security in segmentation.
Travel Buddy is now handling customer credit cards and some personal information. And having everything on one server creates a big security risk for us and for our users. Because if a hacker now broke into our server that runs all these applications, they get access to everything, to the database, to the payment service, everything. So we need to separate things. This is called network segmentation. And subnets let us divide our network into separate sections. Think of it like a hospital that has different floors and wings for different types of patients, like maternity ward on one floor, surgery on another, to keep things cleanly separated. We do the same with our network. Let's say our front-end servers, which are public-facing, go in subnet A with this IP address range, application servers go in subnet 2 with this IP address range, and database servers go in another subnet. So now our network is divided. But wait, if the website is in one subnet and the database is in another subnet, how does the website talk to the database now? And this is where routing becomes necessary. Routing directs traffic between different network segments. When the website needs data from the database, a router will determine the path. So it's basically like a GPS for network data. It figures out how to get from point A to point B. But now we have a new problem. We've separated things into different areas, but what stops everything from talking to everything else? We've created separate rooms, but all the doors are now wide open and unlocked. Just because we can route traffic between subnets does not mean we should allow all traffic in all directions. And that's where firewalls become necessary. A firewall is like a security guard that checks every piece of traffic and decides whether to allow it based on rules traffic
Guys, I really didn't get it. I mean, so here, I really got it from here, subnets, and how the subnets, and I mean the subnets.
its sections.
So because of the security, they're gonna for each application, for each part, they're gonna separate the servers.
Think of it like a hospital that has different floors and wings for different types of patients, like maternity ward on one floor, surgery on another, to keep things cleanly separated. We do the same with our network. Let's say our front-end servers, which are public
Mhm.
facing, go in subnet
So front end is the web application, I guess.
A with this IP address range, application servers go in subnet 2
Application, we're gonna go for the SQL for database.
with this IP address range, and database servers go in another subnet.
I
So
really
now
don't understand about application and database. Maybe this guy is like the SQL, I mean database in the application. The database maybe is where we store the data. In application we're gonna get the payment section. I mean,
our
wait a sec.
network is divided. But wait, if the website is in one subnet and the database is
So if we have uh application database front end, so it's like both I mean all of them are separated. So he's talking about like how we can how we can make them talk with each other.
in another subnet, how does the website talk to the database now?
Wait a sec, yeah. Mhm.
And this is where routing becomes necessary.
Yeah,
Routing directs traffic
between
between
different.
different network segments. When the website needs data from the database, a router will determine the path. So it's basically like a GPS for network data. It figures out how to get from point A to point B. But now we have a new problem. We've separated things into different areas, but what stops everything from talking to everything else? We've created separate rooms, but all the doors are now wide open and unlocked. Just because we can route traffic between subnets does not mean we should allow all traffic in all directions. And that's where firewalls become necessary. A firewall is like a
So here we have routing. Okay, let me add this. We can um, add all the info in one server. Oh, wait, server in B because of mm, because of what? Because of security. Because of security. So we separate them from separate them in three three servers. Okay, and after that, routing comes. Hmm, routing, routing. Then we have firewall.
security guard that checks every piece of traffic and decides whether to allow it based on rules that we set. We have host firewalls that protect individual servers. So we put firewall on the database server and create a rule that says only accept connections on port 3306 and only from IP addresses in the front-end subnet. Anything else gets blocked. But we also have network firewalls that sit between subnets and filter the traffic. So we may place one between the internet and our front-end subnet with a rule saying allow incoming traffic on port 80 and port 443, but block everything else. So if we have another program or application running in front-end subnet on a different port, it will be blocked right away with this firewall rule. So this layered approach means that an attacker has to get through multiple security checkpoints, like the network blocked. Traffic between is divided. But wait. If the website is in one subnet and the database is in another subnet, how does the website talk to the database now? And this is where routing becomes necessary. Routing directs traffic between different network segments. When the website needs data from the database, a router will determine the path. So it's basically like a GPS for network data. It figures out how to get from point A to point B. But now we have a new problem. We've separated things into different areas, but what stops everything from talking to everything else?
What stops everything from talking to everything else? What stops?
We've created separate rooms, but all the doors are now wide open and unlocked. Just because we can route traffic between subnets does not mean we should allow all traffic in all directions. And that's where firewalls become necessary. A
Mm,
firewall is like a security guard that checks every piece of traffic and decides whether to allow it based on rules that we set.
mm-hmm. Firewalls is a security, well, security guard where it checks where it checks where it checks so basically firewalls are it's like a security guard, it's like an antivirus, and it's not gonna allow any uh suspicious I mean anything suspicious to insert to come in our database, I mean our servers. And so yeah, firewalls so they're gonna check for everything and we're gonna give them set of rules, I think. Yeah. Here's explaining.
We have host firewalls that protect.
So we have host firewalls, and we have
Individual servers. So
host firewalls is uh checking the individual servers. I don't know. I think individual is not right.
So we put firewall on the database server and create a rule that says only accept connections on port 3306 and only from IP addresses in the front-end subnet. Anything else gets blocked. But we also have network firewalls
Network firewalls.
that sit between subnets and filter the traffic. So we may
Subnet and filter traffic.
place one between the internet and our front-end subnet with a rule saying allow incoming traffic on port 80 and port 443, but block everything else. So if we have another program or application running in front of subnet on a different port,
network firewall, we're gonna put it every layer and also our internet ISP, IPS, internet providing system. I don't know. Oh, that. Oh shit. Payment. A lot of problems, bro. I have a lot of problems with my English. I have a lot of problems with my English. And yeah.
it will be blocked right away with this firewall rule.
hmm So firewalls are like like firewalls, like guard, where we gonna put them. I mean, in our. I mean, we need it in all. I mean, we need everywhere, you know. And we're gonna give them set of rules like where you need to accept only what they say. Allow incoming traffic on port 80 in port 443, but block everything else. So we're gonna give them set of rules. And I mean, we only gonna allow them like just incoming traffic from port 80 in 443. And so yeah, I'm gonna give them basic rules. I mean, not basic. I'm gonna give them rules for firewalls. So I mean, the firewall is going to uh, not allow anyone to enter our server. That's it.
So if we have another program or application running in front of subnet on a different port, it will be blocked right away with this firewall rule. So this layered approach means that an attacker has to get through multiple security checkpoints, like the network firewall, then the host firewall, to actually do any damage, because security is always layered. With firewalls in place, we have now created secure zones in our network. But another problem is about to appear.
Private servers need internet. Mm.
Allow incoming traffic on port 80 and port 443, but block everything else. So if we have another program or application running in front of subnet on a different port, it will be blocked right away with this firewall rule. So this layered approach means that an attacker has to get through multiple security checkpoints, like the network firewall, then the host firewall, to actually do any damage, because security is always layered. With firewalls in place, we have now created secure zones in our network. But another problem is about to appear.
Private servers need internet. Okay. Private. Version internet. Okay.
Travel Buddy is growing fast. We now have 50 backend servers in a private subnet for security. And these servers have private IP addresses like 10.0.25, 10.0.26, 10.0.27, and so on. So private IP addresses work inside your own network, but they cannot communicate directly with the internet. It's like having an internal extension number at the company. You can call other extensions inside the building, but you can't dial an extension number from your home phone from outside the building, like from your home office. But our backend servers do need to reach the internet sometimes to download software updates, to connect to external payment APIs maybe, or to send data to third-party services. So how do we solve this problem? Because now we have them secured so that nobody can just directly reach them from internet, but they cannot reach internet either. And we can't give each server a public IP address because first, public IP addresses cost money and we need to manage them, and we would now need 50 of them. Well, that's where NAT or network address translation comes in. So NET basically allows multiple devices with private IP addresses to share one public address when accessing the internet. So here's how it works. When reach the internet sometimes, problem is
To be honest, guys, I really didn't understand this. I mean, I understood the firewalls, how they work, and so yeah, after firewalls, we need a private servers, yeah, private servers, where we only can use them. Our company will use it, but they're not allowed to. I mean, we cannot connect them to the public internet. And so yeah, here,
inside your own network, but they cannot communicate directly with the internet.
okay, cannot communicate directly with the
It's
internet.
like having an internal extension number at the company. You can call other extensions inside the building, but you can't dial an extension number from your home phone from outside the building, like from your home office. But our backend servers do need to reach the internet sometimes.
Backend servers. What is a backend server? Let me just check. Backend server. I don't know what is the backend server. A backend server is the behind the scenes engine of an application, responsible for server side logic, database management, API integration, in processing user request. It acts as a bridge between the user interface, frontend, and data storage. It acts as a bridge between the user interface, frontend, and data storage, using technology like Python, Node.js, Java, and SQL database. Um, Backend server. I mean, I think I'm not getting this. Backend server is the behind the scene engine of an application. Okay, engine of an application responsible for server-side logic, database management, API integration, and processing user requests. It acts as a bridge between the user interface, frontend, and data storage, using technologies like Python, Node.js, Java, and SQL database. Mm, Behind the scenes engine of an application responsible for server-side logic, database management, API integration, and processing user requests between the user interface, frontend, and data storage. Okay, let's go and check the pictures like I have here. client, front end, backend, front end, backend SQL. I'm confused. I'm really confused, to be honest. So we have client, we have front end, we have backend. So front end is where we gonna access the internet, but backend we're not gonna allow them. I mean, they cannot access the internet, but they can access the front end. So yeah.
times to download software updates, to connect to external payment APIs, maybe, or to send data to third party services. So, how do we solve this problem? Because now we have them secured so that nobody can just directly reach them from internet, but they cannot reach internet either. And we can't give each server a public IP address because first, public IP addresses cost money and we need to manage them, and we would now need 50 of them. Well, that's where NAT or network.
Guys, so we learned about the firewalls, right? Oh, sorry. Opa. Oh, shit. Oh. So yeah, so we learned about the firewalls, and I think we're gonna stop recording here, and then I will send you the next part also. I mean, we'll upload the next, the second part about the network. So we learned till about firewalls. So what we covered was IP addresses, internet protocol, like each, like IP address. It's really important in networking. And uh, I mean, every site, everything needs IP addresses. So IP addresses, IP address. That's why, like, it's the first thing, really important thing in networking. And DNS, domain name server, how it works is when we want to reach to a site, for example, google.com. And so google.com is the domain name server. But behind that, we have those IP addresses like 127.1.1.1, like there are a lot of them. So people cannot remember them. So that's why we engineers created DNS, so to make them easy, to make it easy. So think it like it's like you were a phone. I mean, it's like the contacts of your family, and you have your dad. So the number is the IP address, but the name you save, like my dad, love you dad, something I don't know, is the domain name server or the DNS. And so yeah, it's like www.google.com. I mean, I can show you and just look up, wait, CMD. I mean, I can show you like how it works. Bring it here. So NS look up google.com. So yeah. This address. So they have basically a lot of addresses. I really don't know. And let's go NS look up YouTube. So, these are the addresses, the IP addresses, basically used to reach to the YouTube. But human cannot, I mean, remember them. I mean, humans cannot like memorize them. So that's why DNS comes here. So we go here, we just write youtube.com. So it forwards us to the YouTube. So that's why it's really important. DNS. So then we have, when we want to reach to a server, we have the web app, MySQL payment server. Web app is this application, the web app, this interface. We have MySQL where we save the data in data, and payment service is also like the database where we're gonna save the payments. I mean, it's really important for every business because payment service where the money talks there. So after that, when we want to wait a sec, ports. Okay, so when you want to reach to a server, so we have three parts, right?
Problem is
Wait a sec.
about.com. Their browser
So yeah, we have the, oh sorry, we have the three parts here, and so here it then the ports come and solve this. I mean, when you wanna send a request to the
automatically
server, and the servers needs to know like where you want to reach. You want to reach to your database, your payment server, or web service or web app. So then, so you're going to the web app. So you type this thing like youtube.com. So you're going, it takes you to the web server. So it needs two ports, 80 or 443. But if you want to go to the YouTube, like you enter the YouTube and you want to go to your, I mean yours, what do you say? Your profile. Uh, so then I think so then they're gonna change the ports 3306. I think so. It works like that, I think. And maybe payment server we have 9090. So yeah, this is how the ports work. And we have ports 443 and 80 for the web app, and we have 3306 MySQL, and 9090 is for the payment servers. We can't add all the info on one server because of security, so we separate them in three servers. So yeah, in here it talked about this thing. So we're gonna, so here subnets come. Oh, and write subnet, root subnets. Subnets are basically network segmentation or uh, separating the servers into three parts. So because of security reasons and not to be hacked. Yeah, because if you have all your data in one server and a hacker comes in, attacks in, then everything is gone. Like it's a big risk. But if you have like one separate server, I mean separated servers, so one is hacked, so still you have some of your informations there in the server. So there's a, you can fix it, and you can lose money by less. But yeah, I mean subnetting is really good. It's, I mean it's logical. And we have routing. Uh, Routing basically connects all the three server in one. So where you can just take one information from first server, application server to the payments. I mean, like all these three servers should be linked with each other, and we need informations from each other. So application server need database server, and they're gonna take the information from there. And payment server needs the database server, so they're gonna take this uh, information from there. And what else we have? The routing FIADA. Yes, yes. And then it comes to the firewalls. Firewalls is like it's like the guard where it checks. And so it's like the guards, like the uh, what do you say? Like the antivirus. I mean, for Windows, I'm gonna say like that. But they're gonna check the security. Like they're not gonna allow some suspicious traffic enter our database. So it's, I mean, if a hackers want to join, I mean, if a hackers want to send traffic in our server, so they're not gonna allow them to enter um in our server. So it's like a protector, it's like a guard, you know, like big arms, which has big arms. Okay. And what else we have here? So we have two types of firewalls, host firewalls and network firewalls. Host firewalls, I think we're gonna install it on database. And it says like only accept connection on port 3306 and only from IP addresses in the front-end subnet. And yeah, and the and we're gonna install the network firewalls for all of them, front-end, back-end, and ISP. And ISP is the internet provider, you know. So we're gonna connect one here between front end and between our internet to ISP. And I mean, we need firewalls everywhere. Yeah. Without firewalls, like everything will be, I mean, a hacker can just hack everything. So yeah, I think I see firewalls everywhere in Microsoft, I mean, in Windows, in Wi-Fi's I mean, Wi-Fi 6, they have, I mean, they have this firewalls everywhere. It comes with firewalls. So that's, I mean, that's really, we need it. So yeah. What else we have? So we're gonna cover up the private server servers. Private servers need internet. We're gonna cover it for the next session, and we have the I mean, we studied until 7:30 minutes, and we're gonna cover it after that. So yeah, maybe I'm gonna post it tomorrow. Maybe, I mean, I will record a video and we'll post it tomorrow, and we'll learn the rest of them tomorrow. So yeah, right now it's late. It's 1:24 a.m. It's night, and yeah. So yeah, I hope you guys learned something from this, and I hope I could explain you like the things which I learned from here for you, for the one who will be listening. And yeah, mm, wish you guys a good night or more, I mean, yeah, night. And yeah, we'll see you guys for the next session. Bye bye.